Video. You have to draw the shear force in the bending moment diagram for a simply supported beam with an inclined load. So there's a loading which is inclined at an angle of 30 degrees. First of all, we need to calculate our support reactions. So we call this side A and B. Hinge has two reactions, a vertical reaction VA, and a horizontal reaction, we call it HA. A roller has only one reaction, we'll call it VB. So let's make use of our equilibrium equations. So sum of moments about point A is equal to 0. You're taking clockwise moments to be positive. 30 kilonewton is going to cause a clockwise moment. So it's going to be 30 times perpendicular distance, which is 2. This is an inclined load. So it's an inclined force, so we need to resolve it into its vertical and horizontal components. So when we resolve it, we're going to get something like this. It follows a sense of pattern. So this is the resultant, and it's here. So that means we need to move in this direction and move in this direction. So we'll move from here to here so that we can get to where the resultant is going. So the direction of the arrow is going to look like this. So we'll come down and move to this side. So to find the vertical part, the vertical component is going to be 30 sine 30 degrees, and the horizontal component is going to be 30 cos 30 degrees. So we are taking moments about A. So this vertical component is going to cause a clockwise moment. It's going to cause a clockwise moment. So it's going to be plus 30 sine 30 multiplying the perpendicular distance. Perpendicular distance. So this is the force, and we have resolved it into the vertical and horizontal component. So it's still acting here. So the perpendicular distance is going to be 4 plus 2, which is 6. VB is going to cause an anti-clockwise moment. So it's going to be negative. Perpendicular distance is 2 plus 4 plus 2, which is 8. So 8 VB. Everything here is equal to 0. So these are the forces causing moments. The horizontal force will not cause a moment because this line of action is passing through where you're taking the moment. So we'll make VB the subject. So we send 8 VB here. You're going to get 8 VB is equal to 60. 30 sine 30 is going to give us 15. So 15 times 6 is going to give us 90. So plus 90. So 8 VB is equal to 150. Then we divide through by 8. Divide through by 8. So this is going to, so VB is going to give us 18.75 kilonewton. And now we have to find the vertical reaction VA. So sum of vertical forces equal to 0. Take upward forces to be positive. So VA is moving up. So positive VA plus VB is moving up, VB. 30 is coming down, so minus 30. And the vertical component is also coming down. So it's going to be minus 30 sine 30. Everything here is equal to 0. Then we'll make VA the subject. So VA is equal to, so VB is 18.75. I'll move it here again, negative 18.75 plus 30. Then this moves here. It's going to be plus 15. 30 sine 30 is 15. VA is equal to 26.25 kilonewton. And that's VA. Then we find the horizontal reaction. So forces moving to the right is positive. HA is positive. Then the horizontal component is also moving to the right. So it's going to be plus 30 cos 30 degrees is equal to 0. So these are the only horizontal forces. So HA is equal to negative 30 cos 30 degrees. And this is going to give us negative 25.98 kilonewton. That's the horizontal force. So we are done calculating the support reactions. So now we have to calculate for the shear force. The shear force. So shear force at A, we'll calculate for two values. So shear force at A prime. The shear force at A prime is equal to 0. And shear force at E is equal to 0 plus. So this previous one plus VA. VA is moving up to 26.25. And this is going to give us 26.25 kilonewton. So this side is B, we'll call this side C and call here D. So shear force at C, we need to calculate two values. So shear force at C prime is going to be 26.25 kilonewton. So the shear force at C is going to be 26.25, the previous one. So 30 is moving down, so it's going to be minus 30. And this is going to give us negative 3.75 kilonewton. Then from there, we'll come to the shear force at D prime. That one is going to be negative 3.75 kilonewton. Then shear force at D is going to be negative 3.75. And when you look at the vertical component, shear force is the sum of vertical forces. The vertical component is coming down. So that's going to give you minus, so minus 30 sine 30. So minus 30 sine 30. And this is going to give us negative 18.75 kilonewton. And we'll come to the shear force at B prime. That's going to give us negative 18.75 kilonewton. Then the shear force at B is going to give us negative 18.75 kilonewton. So this previous one, and VB is here, so moving up. So it's going to be plus 18.75. And this will give us 0. So that's the calculation for the shear force. So now we can draw our shear force diagram. We can call this side A, C, D, and B. A is 0, 26.25 at A, 26.25 kilonewton. Okay, C prime, 26.25. So to be on the same line, 26.25 kilonewton. Then C, negative 3.75. So still a C, negative 3.75. D prime, negative 3.75. So to be on the same line. shear force at D, negative 18.75. So still at D, negative 18.75 kilonewton. Shear force at B prime, negative 18.75 and negative 18.75 kilonewton. Shear force at B, finally you get back to zero. So there's the shear force diagram. This side is positive, the whole of this side is negative. So that's the shear force diagram. So after this, then we have to do the calculation for the bending moment. So let's calculate the bending moment. Bending moment at A, we'll take it to our left because we want to consider taking our left. The negative BMA is anti-clockwise. Is equal to 0. So that means my BMA is equal to 0. In bending moment at C, let's take my left. It's going to be BMC. So anti-clockwise, so negative BMC. VA equals clockwise, so plus VA is 26.25. So 26.25 multiplying the perpendicular distance, which is 2. So these are the only forces that cause moment. Is equal to 0. We send BMC here. So to become positive, BMC will be equal to 52.5 kilonewton meter. That's the bending moment at C. And now the bending moment at D. So that one, let's take our right because when we take our left, we'll do a whole lot of calculations. BMD clockwise. BMD is moving in the clockwise direction. So BMD VB will cause an anti-clockwise. That's going to be minus VB is 18.75. 18.75 multiplying perpendicular distance to D, that is 2. Everything here is equal to 0. So BMD is equal to 37.5 kilonewton meter. And now the bending moment at B. Consider taking our right and call it BMB. So bending moment at B, about B, clockwise, be equal to 0 since there's nothing here. So we can draw a bending moments diagram. A, C, D, and B. So bending moment at E is 0. Bending moment at B, at C, sorry, is 52.5. So 52.5 kilonewton meter. And connect this and this. Bending moment at D, 37.5. Connect this and this. Bending moment at B is 0. So we are going to move from here and come to 0. So this is the bending moment diagram and it's all positive. Thank you for watching this video.